Okay, so we're looking at question 87 of chapter 10, and it says a 55 kilogram runner runs around the edge of a horizontal turntable mounted on a vertical frictionless axis through its center. The runner's velocity relative to the earth has magnitude 2.8 meters a second. The turntable is rotating in the opposite direction with an angular velocity of magnitude 0.20 radians a second relative to the earth. The radius of the turntable is 3 meters, and its moment of inertia about the axis of rotation is 80 kilograms per meter squared. And its moment of inertia about the axis of rotation is 80 kilograms per meter squared. Find the angular velocity of the system if the runner comes to rest relative to the turntable. So we know that the mass is 55 kilograms, the velocity is 2.8 meters a second, the angular velocity is 0.2 radians a second, the radius is 3 meters, the moment of inertia is going to be 80 kilograms times meter squared, and then we know that the initial oh, it slipped my mind. The initial angular momentum is going to be equal to the inertia multiplied by the angular velocity minus the mass multiplied by the radius multiplied by the velocity, and then the final angular momentum is going to be equal to the angular velocity, the final angular velocity multiplied by the inertia plus the mass times the radius squared. That's a mouthful. So then, using the law of conservation, the starting is going to be equal to the final, and so we can use this in our equation. So we get 80 kilograms per meter squared multiplied by 0.2 radians a second minus 55 kilograms multiplied by 3 meters multiplied by 2.8 meters a second divided by 80 kilograms times meter squared plus 55 kilograms multiplied by the radius is 3 meters, and so that's going to give us a negative 0.776 radians a second, and the negative is just indicating the direction.